Have you ever wondered how predictive maintenance plays a pivotal role in power plants? Let's delve into that. In the heart of every power plant lies a myriad of complex machinery, each with their unique roles and responsibilities. The health of these machines is integral to the smooth operation of the plant. Here's where predictive maintenance steps in. By harnessing the power of data, it foresees potential equipment failures before they even occur, ensuring the plant's machinery is always in optimal condition. But that's not all. Predictive maintenance also significantly enhances safety. By identifying potential issues early, it minimizes the risk of catastrophic failures that could endanger employees and the surrounding environment. Additionally, it reduces operational costs. Think about it. Proactively addressing minor issues before they escalate into major ones saves on expensive repair costs and prevents costly downtime. So, predictive maintenance is not just a luxury, but a necessity for power plants. Let's delve into a real-life example where AI dramatically transformed the predictive maintenance approach of a power plant. Imagine a bustling power plant with its heart beating in the form of heavy machinery and equipment. These mechanical marvels, though robust, are not invincible. Breakdowns, wear and tear are inevitable. But what if we could predict these breakdowns before they occur? That's exactly what one power plant managed to do by implementing artificial intelligence. This power plant was plagued with frequent and unpredictable equipment failures, causing costly downtime and safety concerns. The key to their solution was in the data. The plant was already generating a wealth of data through sensors embedded in their machinery, collecting information on temperature, pressure, vibration, and more. But until the introduction of AI, this data was significantly underutilized. The power plant implemented a machine learning model, a subset of AI, to analyze this data in real time. It learned from historical patterns of equipment failure and was able to predict potential breakdowns